Hello and welcome back to another installment of medium LeetCode problems. We're looking at 3100 water bottles version 2. I remember the first water bottles, solved that one this week, which had a closed formula for calculating the number of bottles, and an iterative one that was, I think it had a log time complexity. So now we're dealing with version 2. So let's see what this is about. I have not tried this one before. So you're given in two integers, num bottles and num exchange. Num bottles represents the number of full water bottles that you initially have. In one operation, you can perform one of the following operations. Drink any number of full water bottles and turning them into empty bottles. Exchange num exchange empty bottles with one full water bottle. Then increase num exchange by 1. Okay, that's the twist. That's new in this part 2 problem. Note, you cannot exchange multiple batches or empty bottles for the same value of num exchange. For example, if num bottles is 3 and num exchange is 1, you cannot exchange 3 empty water bottles for 3 full bottles. Aha, so okay. So we get num exchange. Well, we have to put num exchange bottles in. Then num exchange bottle goes up. And if we still have empty bottles, we just repeat that. Return the maximum number of water bottles you can drink. Cool. We have at least one bottle, and num exchange is now 1, or, well, it doesn't matter because it's going to be 2 in the next exchange, right? So, but it's good to know we have at least one bottle to drink, and our exchange rate might start at 1, even though it's going to go up. So example. What do we have here? Num bottles is 13, num exchange is 3. So we drink 13 bottles. So we add that to our total result. We have num exchange is 6. So we exchange 6 of the 13 bottles for 1 full bottle, and we're left with 7 empty bottles. Now we have 7 here as well, so we can exchange one more time. Then we have 2 bottles. Now exchange went up, but we have less than exchange bottles left. So we can drink 2 more bottles and it increased. Okay, understood. Next example. So here we start with 10 full bottles, right? 10 full bottles and exchange at 3. We drink 10. We have 10 empty. So we exchange 3 for 1, which leaves us with 7. Then we take we exchange 4 of our 7 for another bottle. We are left with 3. Now we cannot perform any more exchanges. But we can drink 2 bottles. Now we suddenly have 5 empty bottles. And we can make one more exchange and drink it and add that to our thing. And then, yeah, okay, cool. So again, I don't know if that's a close formula for this, but I would just implement it straight away as this algorithm is shown here. What's the runtime complexity? Well, at every step, we have less opportunity to exchange bottles, right? So we always have one step of our initial number to consume our initial number of full bottles. And then after that step, we are inside a little loop where we perform these checks. So if we have 13 bottles in num exchange, so we have a log. I think we have a logarithmic time complexity because at every step, except maybe the first, we are at least halving the number of full bottles. When the exchange rate is 1, we don't have it. Half it, H-A-L-F, half it. But after that, num exchange, well, yeah, after that, you know, when num exchange also grows, it just means we get less and less bottles. So from 13, we immediately go to, well, this is actually going to 1 to 0. So this, I think we'll still have logarithmic time, O of log n time, and O of 1 space, because we only need to store, you know, all of these little numbers that are in a row. And yeah, and we could just, you know, I mean, implement this straight force. I guess that would be the brute force approach. So the result is we initially drink all of those bottles, and then we have empty bottles equals num bottles, while empty bottles is larger or equal num exchange. That's what we do. So now what we get, full bottles equals num exchange. Num exchange goes up by 1, right? That's we have like a inflation. So full bottles equals num exchange, empty full bottles. Now we say result plus equals full bottles equals, wait. Well, we get 1 bottle back, right? Empty bottles decreases by num exchange. So while we have more empty bottles than num exchange or equal, we give num exchange empty bottles to the market and we return 1 full bottle for it. Now, after our transaction with the market, the price goes up for exchanging empty for full bottles. So full bottles is 1 now, right? So that means we can drink 1 more bottle. Now suddenly number of full bottles is 0, but number of empty bottles has increased by 1. And we continue with our loop. So yeah, and at the end, we don't have enough empty bottles to exchange them anymore. So we're done. And if we run this little bit of code, we get the correct result. We could simplify this if we wanted to. Is there a point in doing that? Well, yeah. The full bottles equals 1, and then we set it to 0. So we could just do this. Full bottles, we don't need the full bottles variable. The empty bottles is num exchange, is subtracted by num exchange, but then we're adding 1 to our empty bottles all the time. So that is the same as saying empty bottles equals empty bottles minus num exchange plus 1. Cool. Yes. So that shouldn't change anything. Let's just submit this to see if it works. Very nice. And we're on a streak, also nice. Yeah, okay, now let's have a look at maybe some of the solutions that people have. Maybe somebody has something nice. Water bottle, simple approach, easy solution. No loops, closed form, interesting. So there's a closed form for that as well. So some math whiz took the time to analyze this and found this magnificent formula for it. Yeah, you're not going to be asked to come up with that in an interview. Exactly, yes. Yeah, well, so that exists, but I think it's completely irrelevant for coding interviews, right? Has more of a puzzle effect. So yeah, I'll leave it at that. And this concludes this medium problem.